see. So
Düsseldorf, Germany. Sabrina, guten Tag, good evening.
all right, just about set up here. So hi everyone, if you're joining us on LinkedIn and YouTube, we're just about to go ahead and get started here. If you can drop in the chat where you're joining us from, we'd love to hear where you're located. All right, Boston, Minnesota, East Coast Canada, France. Hi everyone. Park City, Utah, Sacramento. Awesome. All right, I'm just going to share this link. And then I think we're good to go ahead and get started. So I'm just going to share my slides here for a second. I just have a quick couple of intro slides. All right. So thanks everyone for joining us. This is a tech talk on MLOps on Azure Databricks with MLflow. And we have Oliver and Jules here today. So this is part of our Data Plus AI online meetup group. The link's there if you're joining us on YouTube and LinkedIn. I'd love for you to check out the group. And we have another event coming up next week, and that link will share all the details with you. And if you're joining us on Zoom, we also have all of our videos posted on YouTube. So I invite you to check out our Databricks YouTube channel, and we have all the content there. We have all the awesome content from our Data Plus AI online summits and LinkedIn too. We also stream to LinkedIn. So welcome everyone who's joining us there. So one thing I wanted to mention, we have a really awesome podcast series called Data Brew, and it's hosted by Denny and Brooke. They explore various topics in the data and AI community, and they interview a variety of subject matter experts in data engineering and data science. So the link is at the top. I'll also drop that in all the chat spaces, but you can get it wherever you like to listen to your podcasts. And I believe they're up to, probably by now, up to over 5 episodes. So we have all the details in that link. So I invite you to check those out. So quick call out, our next online meetup is actually a data collab lab with Franco and Lee. That is going to be next Tuesday at 9 a.m. Pacific time. So scaling and automating R with Databricks. So check out that session details, and hopefully you can join us there next week. So quick reminder before I pass it over to Jules, the session is recorded. It'll be available immediately after on our YouTube channel. So if there's, if you need to hop off, no worries. The content will be there for you to view as you wish. So with that, I would like to pass it over to Jules.
Well, thank you, Karen, for this warm introduction to our meetup and all the activities which are actually happening. Once again, welcome to our first MLflow meetup as part of the larger umbrella Data Plus AI meetup into the new year. Now, those of you who actually have been following the predictions of some of the technical trends happening in the areas, in particular in AI and ML, you will have heard that this year is a year when the MLOps will be an essential best practice in the entire model lifecycle management. And that is because more and more machine learning models are prominent and being developed and trained and tested and deployed in production in all sectors of the industries and in all areas of data processing. And in particular, one discipline or one concept that was actually borrowed from DevOps, the continuous integration and continuous development is an important part in the entire ML lifecycle. So it is quite fitting today to just start off the new year with this particular meetup. In today's session, we will focus on how the managed MLflow Databricks, its model registry features, and the Azure ecosystem facilitate this best practice of MLOps lifecycle for managing and deploying models at scale. And joining us virtually from New York today is my esteemed colleague, Oliver Koenig. He is a solution architect with a decade of experience in big data and ML, and especially finance in the financial industry where he focuses quite a bit. And as a reminder, please post your questions in the Q&A panel if you're joining us in Zoom, not in the chat, because it's going to be difficult for us to monitor. I'll be also monitoring your YouTube and LinkedIn channel to any questions, and we'll try to address them towards the end. The questions that I can answer, I'll answer impromptu. So Oliver, it's all yours. Take it away. Tell us all about it.
Thank you, Jules. Let me share my screen here to get started. Can you see my screen?
Yes, we can.
Okay, good. Yeah, so welcome everyone to the Tech Talk. We're excited to have everybody on. The one thing I wanted to mention is that most of what I'm going to talk about today, I already wrote about in a blog post that was published in October. For any type of detail, you can also go to that blog post. I'll be happy to send you the link. I also have it on the slide here as well. And so just to get things started, like Jules just mentioned, I think companies have been doing a pretty good job by now to manage a traditional software development lifecycle. So that would typically involve, writing code, writing unit tests, reviewing it, getting the appropriate renewals, and then basically releasing the code and automating most of that, to the degree possible. The MLOps lifecycle, while similar, has also a couple of key differences. First of all, typically you focus on a machine learning model itself and the underlying data, as well as, of course, the code that you write, versus in a traditional software lifecycle, the code typically works more or less deterministic, versus a machine learning model can change if the underlying data can change. So it's important that a machine learning model will be actually retrained and redeployed over time, maybe more so than even a traditional software. And so basically this cycle on the right-hand side, there's not a lot of maturity, I think, in most organizations as you do it, partially because, the tools haven't been, are still emerging, and the things have to be integrated, not well understood. But there is certainly a growing ecosystem of tools and services that can support that. So one of them actually is MLflow. So some of you may be familiar with MLflow, but just a brief overview. MLflow is an open source project that is very, very popular now. I think we have 2 million downloads last month. And it was originated and is spearheaded by Databricks, just like Spark as well. And it becomes one of the most important open source projects that we're involved in. And the idea of MLflow is not to build yet another machine learning library, but basically to manage the flow and the life cycle between building a model, running experiments with a model, and then providing access to the model and deploying it. So typically you have a myriad of open source machine learning libraries such as TensorFlow, scikit-learn, XGBoost, and so forth. And they're all very different in many ways, SparkML. So what MLflow is trying to do is basically building a wrap around it that says, well, they're all different models, but they're all, they're all machine learning models. So we can also treat them as a model as a whole. They have different flavors of models. So we call them model flavors. And so, so basically you can, manage these models, even if they're different, if they're different underlying frameworks, in a similar way or in the same way. And then the second part, what MLflow is doing is tracking the execution of the model. So when you train your model and when you run it and you're trying out different types of models, different parameters, it actually tracks all that and keeps the matrix and actually can tell you, okay, this was actually the best model and can show you the difference. And again, it does that for a large variety of models that are out there. And then the next step, when you have found a really good model, then the model registry comes in, and that's really going to be the focus of our session today. The registry is really something where you can promote the maturity level of the model to the point where it can be put into production. So initially you would maybe deploy the model just as a regular entry, and then when you think as a data scientist, this model is actually good to go, you can put it into a staging phase, and then that staging phase will kick off some kind of automated pipeline that will test the model and put it into production, in theory all in one shot. And then so putting in production really means there's a whole slew of options that you have to put a machine learning model in production. So on Databricks, you can actually do a batch and streaming scoring, and you can also use single node rest scoring. You could also just have a very simple set of Python code, for example, that just runs the model, or you can just put it in a container. And then Azure has its own environment called Azure ML, which also container-based, but it's specifically designed for machine learning models. So that's going to be the focus of the day. So MLflow has actually APIs, deployment APIs to each of these individual scoring endpoints, if you will. And then the other key aspect of what I'm going to talk about today is the CI/CD, an automation aspect of this. And a very popular option within Azure is Azure DevOps, and specifically the Azure repository and the Azure pipelines tool. And the idea is that there is actually a new feature in MLflow that's a webhooks feature that would automatically trigger pipelines that are related to, for example, testing a model from going from staging to production. And that's something I want to showcase today. Just a quick disclaimer here. So the preview feature that I'm going to show you today is, again, it's in private preview actually right now, so it's not publicly viewable. We're still getting feedback from customers how it works, so it may change, or actually there's also change, may not be released at all. And then there is no formal support available and things like that. So if you're interested in this feature, please reach out to your friendly neighborhood Databricks representative, and we can help you get started with that. And there's no charge for it, of course, for the duration of the preview. So let me give you a different view here. So the one thing I want to just quickly do is, I'm going to show you a whole bunch of tools in the next 20-30 minutes or so. So I just wanted to give you a little graphical view of kind of what's going to happen. Because sometimes it's hard to then see the forest for the trees. So basically, there's kind of three major components to this. One is Azure Databricks. So Azure Databricks basically has the notebook environment. So I have multiple different notebooks. The one I use for training, and then also one that I use for deploying and testing. And then it has a managed MLflow instance, meaning you don't have to set up MLflow. It's there. The registry is there. There's UI components and so forth. And I'm going to show you that. Then there's Azure ML. Azure ML itself also has a whole bunch of components. So there's actually a workspace that allows you to view the components. And then there's the container environment that allows you to create the endpoints that you can then use, for example, to do a REST scoring deployment. And then kind of in the center of this is Azure DevOps. And Azure DevOps has, there's a repo component. So all the code that is being produced, which Python exclusively, and some YAML files, actually the pipeline itself, are stored in this repo. And then the Azure Pipelines model will, basically has the workflow that's needed to to control everything that's going on between all these different components. There's also one thing that I more recently added to support webhooks, which is a serverless function that basically allows to create API endpoints, and that's something that you need if you want to use the webhooks feature. So what's the flow here? So the first thing, when you train a model, you actually, again, you're going to go through a cycle until you have a model that you like, and then ultimately you're going to promote the model to a staging phase in the model registry. And that can actually, two different things can happen after that. One is you would then manually trigger the pipeline that you need to run. So that would depend a little bit on, the data scientist or whoever would be doing it to know exactly which pipeline to trigger and, make sure that the pipeline is actually triggered. So the second option is actually to use the new webhooks feature that I'm going to show you, which basically automatically will trigger an event that somebody has promoted something to staging, and then it will automatically trigger the underlying pipeline. So that's much more robust and less error prone than doing it manually. And then the pipeline itself will actually trigger another notebook in Databricks that actually says, okay, deploy this model into the Azure ML environment, and then make sure everything works fine. And then everything that works fine, put it into production. Okay, so then the model will actually retrieve the staging model that was previously published here. It will then use the API that MLflow provides to publish into the Azure ML environment, which actually going to create the containers and the REST API that would allow the scoring of the information, and then it will hand it back to pipelines. Will then in turn, call another Python notebook that will do some testing. So the test could be very elaborate here, right? But all I'm doing here is just making sure that the REST API is accessible and returns like a meaningful value, right? It could be, more content-based, but it's just to keep it simple. And then if the test is successful, then, you actually promote the model to a production level model, which could then actually trigger another pipeline to, for example, then, put the models into a true production environment, or replace the production model environment that's currently available. Okay, so that's kind of in a nutshell. I was going to show you how this looks like in the individual tools. So the first thing we're going to start with is the Databricks notebook. So I assume most everybody is going to be familiar with the Databricks environment. This is a notebook within the Databricks environment. All the code that I have is actually synced up with the Azure DevOps repo. In this case, the master branch, could also be development branch or some other branch, but everything is kept in sync here.
Oliver, just to interrupt,
sure.
Could you focus a little bit more? So zoom out. I mean,
zooming out. Okay.
Yeah, zooming out. Yeah.
Like this.
Zoom out. Yeah. A little more.
Like this.
Yeah, that's good.
Okay, sounds good. Cool. Yeah. So this is the notebook that does the training. So again, I'm not going to go very deep into that. It's typically what happens is it's going to do some tracking, with MLflow in terms of the experiments. There's some training data. So the business scenario I'm using is there's a wine training set. So basically, a set that has the chemical compounds of wine, and I can train that on an existing set. And then if you're analyzing new wine, you want to predict what the quality of that wine is that people would typically associate with. Would it be a 9 or a 10 score, which would be great, or would it be a 1 or 2 score, which would be not so good? And so the assumption is you would retrain this model as you get more feedback on the wines that you may have tested. So in this case, this is going to be a simple scikit-learn model. Again, I'm not going to focus on the data science itself. It's very simplistic. And then the key is at the end of the day, am I going to actually put it into my registry? And I'm going to call the model a wine model with my initials added. So so the experiment is actually tracking here, and it's checking the model into the registry. It's going to give it like some metal. So actually, what it tells me, it actually created version number 5 of the model. So within Databricks, there's a view here that allows me to look at the model themselves. So that's the models tab here. So let me go here. So this then allows me to see, what are the available models, what are the version of the models, and what stage are the models in. Okay, so I can actually do a search here, since I know this is going to be called this here. So I see actually version 5 is what I just actually created running the workflow. By default, it actually will put it into a non-stage, meaning it's just something that somebody checked in that has no particular things. And I can actually see that actually version 4 of the model is actually the one that's in production right now, right? And there's no other staging models here. So again, if I'm the data scientist, I can say, okay, or the administrator can say, okay, this is actually a good. I feel confident that this is a good version of the model. So let me deploy that. And what I can do is I can promote this model from the non-stage into the staging stage. And so there's multiple ways to do this with a registry. One is actually just to request the transition. So some, administrator may look at it and make sure it will acquire all the values. Or I can actually transition it right into staging. And of course you can control the permissions that individuals will have on what they do. So in this case, I'm just going to promote it directly into staging. So I can actually put a comment here saying this looks good. Please test. Right, and then I can actually, create this new staging model. So the one thing that I would expect here is that the pipeline that will actually then control the end-to-end flow would be automatically triggered here. So hopefully that's the case. Let me go here. So now I'm actually in the Azure DevOps environment. And again, there's this is the Azure Pipelines option. And this is actually the pipeline that I have triggered, which is called ML Governance v3. And I can see this little symbol here that this is actually running. So this was actually triggered by the process of me putting that model into production. The webhook was automatically triggered, so I can actually see, each individual step that this pipeline is actually going to go through. So I'm going to come back to that here in a second. The one thing I wanted to show you real quick is, in Databricks, what this webhook actually look like. So currently, as I mentioned, we're in a preview phase. So you have to basically create the manual hook, or the webhook manually using an API call. And so actually I do have another notebook that simplifies that the use of the REST API. So there's a set of APIs around webhooks in MLflow. For example, there's one that lists all the webhooks that are in place, and I can actually do this quickly. And so what this tells me is, well, now actually I only have one webhook, and it is actually it has an ID, and it's tied to this particular event. And that event was actually the actual transitioning from one stage to the next. And what this webhook is actually doing, it's triggering an endpoint, an API endpoint that will basically able to retrieve more detailed information of how this event took place. And this is actually an endpoint that I created in using the Azure functions model. So if you go into the Azure environment and you look at the webhooks functions, this is actually the function that I created. I can click on the particular function itself, and I can actually see what the code is of that function is. It's a simple Python function. So what I'm doing here is, I'm getting the request in, and then essentially what I'm doing is, if this is something that goes to the staging phase, I'm going to trigger another API, which is the pipeline that I just triggered, right? And I'm doing this by number. So I know the number of this pipeline that I triggered is number 6. So I could actually trigger multiple different pipelines over time. So this is actually quite straightforward. I can also then I could create an additional webhook using the API, and then I can also delete webhooks if I don't need them anymore. The webhooks are currently tied to the name of the model. So if I would have created a new model and with a different name, nothing would happen if I put it into staging unless I would create another webhook that would do a similar thing in the model transition. Okay, so now we're at the point where the pipeline is running. So let's take another look at what exactly is going on in this pipeline. So if you've used Azure DevOps before or similar CI/CD tools, the first couple of steps are always like setting up the environment. So for example, in this case, it's installing a Python 3 environment. It loads some dependencies, such as the Python wheel. It will install the database command line interface, which will allow you to interact with the Databricks environment. It will then do a checkout of the branch that includes the most recent code, and then it will actually do the import of the notebook. So what this means is this deployment notebook that I'm running, then that's the one, if you remember, that actually will basically hand off the model into the Azure ML environment. That's actually happening here. And then, so you can see that this is the active stage in the pipeline that's currently running. It's running for about 4 minutes. So from previous experience, I know the total runtime of this particular step takes about 12 to 13 minutes. So it has a little bit of a ways to go. But I can actually see, on my Databricks environment, I'm using the Databricks REST API here to trigger the job on the Databricks cluster. And that's something that I can do using a script that I created. So basically the script, which is also in the underlying repo here, it's actually called executive notebook, not executive, execute notebook.py. So think about it as a Python wrapper that makes it easier to interact with the REST API that allows access to the Databricks environment. And all this is doing is it will trigger a job for a notebook. So as you're familiar with Databricks, you know that you can run automated jobs on Databricks that can either use an existing cluster or spin up a new cluster, and then do what it needs to be doing, and then shuts down the job otherwise. And what this Python script is actually doing, it will sort of wait until that job is done. So every 10 seconds, it will ping, has there been a result here? So you can see this. Has there been something happening? No, then wait another 10 seconds until either, until the job succeeds or the job fails. So if I go back to the Databricks environment, I can actually take a look at what this job is currently doing. We know it's been running for like 5-6 minutes. So if I'm curious to see what's going on here, I can see this list in the job here. So I can see this is the notebook that's been running. And the way I configured the running is that it uses an existing cluster to do the run, because it's faster to get the job started. In reality, this would be a new cluster, because that cluster would then only run for the 12 minutes where it actually would be running, and then it would shut down again. But you can see here that what the run actually did is there's actually an SDK environment for Azure, which allows you to programmatically deploy the Azure ML workspace, and then there's some setup to be done here for the workspace. So the key piece that I wanted to show you is that MLflow has a particular set of libraries, particularly for the Azure ML environment, and it's very easy to basically do a one command line deployment into the Azure ML environment, right? So this is basically what's happening. It's actually giving you the URI of the model, meaning the locator of the model in the registry. Again, you have to know which workspace you're deploying it in, and so forth. And then you can also, for example, add some tags with some metrics of the model, and so forth. So this is actually what's currently running. I see this because it says it's running here, because that takes the bulk of the time on the Azure ML side, is basically provisioning the underlying containers that will host that model eventually. I can actually go into the Azure environment here itself. And so now I'm in Azure ML. And in Azure ML, I can actually see, for example, which ones are the models that I'm doing with. So this is actually the one I was just handing off to the environment, which is, again, has some information. It has some of the tags and some of the metrics that I provided. And this is actually the model that's currently being deployed. And then the endpoints, right now there's no endpoint available because the endpoint hasn't been created yet. As soon as my notebook run will finish, it will actually create that endpoint and make that endpoint available for testing, right? Which is kind of what I'm doing here. So go back to my pipeline. So this is still a couple minutes to go. So what I'm going to do is I'm just going to go to a previously finished job. So I think I actually ran one this morning, about 3 hours ago, that actually finished successfully. So I can just click on this and see kind of what was going on here. So you can see here, this particular step and that particular job was successfully finished in about 13 minutes. The output of this was actually a REST API link. So again, when I deploy this wine model on Azure ML, I now have a containerized environment that has a REST API that says, okay, give me all the compounds of the wine, and I calculate what the predicted score is of that wine. Okay, so this is what the URL that's being handed back to me. So I can say, okay, now I can actually go ahead and test if this is actually doing what it's supposed to be doing. So that's actually what's happening here, where I'm actually going into my test notebook and then test the MLflow against the REST API. So that's another notebook in my environment. So let's open this up. Okay, so here's this particular piece of code that does that. Again, what it does, it just basically install the same type of libraries, and then it will just call that particular endpoint with I think it's just one random number that it picks from the existing data set that's out there, and just to see if that if the results is going to be the expected result, right? And then in this particular case, what's happening, it actually it returns a score. So for this randomly picked wine that was sent to the wine is like a 5.6, so it's just slightly above average wine basically. And then the next step is, okay, this all looks good. I'm actually going to promote this into production using the registry. So this is another step, in the flow. And what's happening here is it actually uses the MLflow API directly in Azure DevOps to trigger this particular pipeline. So I can show you, in one of the other scripts, apart from the one we already looked at, are 2 scripts that are related to MLflow. And this particular short script here, what it does, it also triggers the pipeline, the transition model in MLflow, and it says, okay, give me the latest version of the model that's in the staging stage, which that should be the one, because we checked one in. But for some reason, if there wouldn't be one, it would actually create an exception and terminate the pipeline. In this case, I actually want to put this model into production, to make sure it's I can then use that model to use as the production level model here. Okay, so if I go back to my my pipeline here to see if that pipeline is still running, see if we passed that initial deployment step. Okay, so it should actually finish in the next couple of seconds here. So let's give it a little bit of a wait here. So I'm actually going to, in the meantime, go back to my model registry in my Databricks environment. And I should actually see here. So I see that, I haven't reached that stage yet. I still have my staging model in version 5, and I have my production model in version 4. So what I would expect is, any minute here, this step to finish, and then, once I get to the step of promoting the model into staging, I will see actually the transition to the production level. So let's give that a few seconds. Hard to completely time it. It actually takes a little longer than the run I had this morning. Also depends on how many things are running at the same time, within the Azure ML environment. Of course, now it takes longer. It's Murphy's Law, I guess. But just to come back to this diagram here one more time, just to put the big picture up. So I'm basically in this step where I'm still deploying this phase here, and I'm basically waiting for handing the REST API back to the pipeline that it can then basically execute the test now. This is all going to happen very, very quickly. Again, this was I don't do very much in the testing side except for just testing that the REST API itself is working and returns something. So now it actually takes 12.5 minutes. Okay, that's not bad. But it's and then it basically comes back to the registry and promotes it in the registry. And the way I've written the pipeline is you actually would actually take a look at the pipeline. I skipped that step when we looked at this earlier, so that's a good use of time here. So as I mentioned before, and that's similar in most CI/CD environments, that there's a YAML interface that again, and every step that you saw happens through YAML, and this also then interacts with the Databricks CLI. And it'll then also call the Databricks scripts that I had shown you earlier, up to the point where so this basically controls what's going on with the pipeline. And this YAML file itself is actually versioned as well in the repo itself. Okay, so let's see here. I have to click on the wrong place. Okay, so let's take another look at this job here. For some reason it takes much longer than before, but again, looking at the pipeline I had this morning. Sorry, I'm going to click on the right thing here. So this is again the one that I looked earlier. So what happened here was, when actually sorry, I'm just going to refresh this really quick. Okay, so what happened was when I transitioned this, as you could see, initially I said, hey, this looks good, ready for testing, and this was then transported into the production phase. So what I did was, basically closing the loop here. I automatically triggered a deployment pipeline. I then basically put the model into the registry. I triggered, I then deployed this on the Azure ML environment. I tested that the Azure ML environment is working, and then I promote the model into production. And of course, you can always think that there's like a manual step in between that would allow people to interject and have some kind of a manual approval by someone, which I think is common. But again, in theory, the tooling would certainly allow you to completely automate this this step here, right? So yeah, so I think that was I know there was a lot of tools and a lot of things in the same environment. What I hope you could see is that through ML Flow, you can actually control the artifacts that are at the center of a model lifecycle, which is the model itself, and you can actually manage it through the individual stages. And you also have ways to automatically trigger external services. In this case, I'm using an Azure pipeline, but you can also think about, hey, maybe it just sends somebody an email. Hey, somebody checked in this in production. Please take a look at that, or a Slack message, and things like that. So it's not necessarily just the pipeline that would automate trigger, but there could be other ways to react to the fact that somebody promotes something into the staging area. But again, this will allow, so oftentimes from what I've seen in various organizations, the models are just stored in some kind of a file location or maybe an object store location, and it's hard to keep track over time. Is that the right version? Which data actually was used when creating this model, and things like that. So actually, MLflow provides a lot of help in producing this environment. And so the particular flow that I picked here, which was all Azure services, I was going to give you some inclination of how you can use the available tools in a collaborative manner to manage the end-to-end flow. And with that, I see if Jules, if there are any questions that came up during the call.
Thanks a lot, Oliver, for this end-to-end life cycle. You can see there were actually quite a few moving parts, and this is the whole idea behind having a continuous integration and continuous development borrowed from DevOps, because the ML lifecycle is an iterative process. And as Oliver showed some of the ways that you can actually get notifications for these different stages of the model as it evolves and take appropriate action in your CI/CD cycle. Okay, so some of the questions that I come, let me go all the way back down to Florent, who said, why are you using deploy.py instead of doing this directly with Azure DevOps and CLI Databricks? So I think earlier you were showing the deploy.py as a separate job directly. So why not do that directly in Azure DevOps, or use the command line Databricks CLI?
Yeah, and that's a fair question. There's actually different places you can actually execute the code.
Right.
I chosen to run all the code that was related to MLflow right on Databricks, right? Just to make sure that I can directly use the available services that Databricks provides. But absolutely, I could run it in, in the CI/CD environment, or in some other way. So there's different options there. That's a fair point.
And I think a similar question from the same person, but slightly different, is are you using the single Databricks workspace, or do you have a different workspace for the development environment, the staging environment, and production environment? Because in model registry, we allow people to have different registries. So where are you actually doing all this? Are you doing all this in single workspace?
So the demo is all in a single workspace, but absolutely, I think if you're doing this for production, I would separate, probably create 3 different workspaces like you suggested. The development will actually develop the code and run the training, and then the QA and the dev where we do the testing, and then ultimately the production level model.
Another question somehow related to performance profiling. Is there any way you can actually profile the CPU and the memory usage of the image classification in a notebook, and then use the same thing on Azure ML? Can you do that in Databricks? I think he's asking, how can I profile? How long does it actually take me to do the training? And I believe, and I'll try to answer the question and add comments to that. I think one of the things you can actually do is the ability to time how long it actually takes to do the training along the epochs, because those are part of the metrics that you actually get. And you can log those metrics as part of your training exercise, and you can export that into something like Grafana or something like Prometheus, which can actually deploy you as a dashboard. I don't know, is there something equivalent functionality in Azure ML you can actually do it? Do you know anything about that, Oliver?
I'm not too familiar with Azure ML. Basically, it's just using it as an endpoint here. And not so much for the training part. So I don't know the answer.
Yes. Yeah. I mean, I think the way I would approach is that I would actually capture all the training data, how long it actually take me for each epoch, and once I've done the predictions, I can capture the times for that and deploy and log that as a metric in the MLflow experiment, and then take that particular data and put it in and create dashboards for those. Those people actually do that for monitoring. How long does it actually take to run that thing? Something related, I think, is once the model is deployed, is there a mechanism in place to do model performance, in particularly decaying over time, or how do you actually detect input drift detection to retain the new model version? And how would you integrate that into the CI/CD? That's actually a good question.
It's a great question. And so right now you have to do this manually, basically, right? So you would have some pipeline or some other piece of code that would track the performance automatically. But it is actually something that's on our roadmap. Model drift detection is absolutely something that we want to add.
Yes, Jess, I think this is, yes, Jess, as Oliver pointed out, this is an important element. And one of the other missing pieces is how do you actually detect model drift, because data changes all the time, features changes all the time. And when that actually happens, you are forced somehow either to retrain the model with the new data to make sure that the predictions are valid. And then how do you actually detect the data drift? And yes, there are external ways, as Oliver pointed out, that you can actually do it, but it is part in our roadmap to provide that as part of the functionality so that you can actually do that. And that way you can use webhooks to notify something that you actually detected as a saying, now go ahead and train this model with this new data set. Okay, we got lots of time, brilliant. People want to wonder how can you actually get access to all the code that you've seen? There's a lot of code that you actually show. Is there any way eventually you can provide us as a GitHub repo or something like that?
Sure. So the link to the blog that I have includes all the Databricks notebooks that I've been using, but there's also like the YAML file for DevOps, and there's also the Python scripts that I use within DevOps. That's actually in an Azure DevOps repo. It's not easily available, but what I'll do is I'm going to clone it into a public GitHub repo, and we'll send that out after the call. Right now, it's just kind of stuck inside of the Azure environment.
Is the MLflow instance or server attached to a workspace?
Yes, it is. So and you can access so you would have to pick right now a repo, a sort of a repository, a registry. You can actually do that across workspaces. So just using the REST API, the REST API doesn't care if it's in workspace A or workspace B, but you would not use multiple registries across multiple workspaces, but use a single one.
Let me see if there's any questions on YouTube. There's a question about in this whole process of the CI/CD, it's possible that the data changes. So how do you actually keep track of the data versioning? That's a good question.
Yeah, that's a great question. It's probably for another discussion. But what we typically do with Databricks is there's another open source project that we're spearheading called Delta Lake. And Delta Lake is, typically what we recommend as the default storage mechanism to store data in the data lake, and that has an automatic version mechanism. So every time you make changes to the data, Data Lake will actually keep track of the version of the model, and MLflow will automatically, if you use Delta as the underlying data source, which I actually didn't do in this particular demo, you would actually point back to the version of Delta that was used. So you can actually go actually in the registry when you I'm just going to quickly show this here. When you click on a particular model, go back here. Where was I here? Yeah, so I can click on this particular model, and I can go. This is the run information. That was the one that was on the MLflow tracking server. And actually see this reproduce run. So this would actually automatically reproduce the run of this model in the version, and again, with the appropriate data version that you have if you're using Delta as the underlying storage mechanism.
Yeah, and just to add what Oliver was saying is that I think one of the important part, not only as part of the operations, but also in part of governance in how do you actually find out or track the lineage of how the model was deployed, what data sets was used, what inference what data sets were used, who actually touched the model. The model registry actually provides you the ability to not only give you the lineage of how the data evolved, but also the provenance of who actually touched the model through these particular activity. Now, if you actually wanted to reproduce that particular model that you actually deployed using the webhooks, one of the things, as Oliver pointed out, was that you can actually track or tag your model with the data, with the Delta version table that was used to train the test and validation data. And that way, when you go to that particular model in the tag, you can actually see the table version for the Delta, the training data available, and the validation data available. And that way, you can actually reuse the data to retrain it. So Delta Lake is an important part in our managed solution to allow you to provide you this data lineage and the ability to reproduce the model and go back in time, how you actually got the data, where you got the data from, and that way you can actually reproduce that. Okay, I think we have a couple of more questions here. Can you please tell me the Databricks endpoints? I'm not sure what he means by that. I think he actually meant by the endpoints that the webhooks actually creates, right?
Yeah. So basically, there's an endpoint for the API, right? That depends on the workspace. So typically, there's going to be whatever your workspace name is, and then /API/MLflow. So that will be the endpoint for creating the webhooks, and then the endpoint itself that you use can be any endpoint that you choose, right? So in this case, I created a separate endpoint that was an Azure function. And I used, when you create the webhook, you would then specify this particular endpoint in the Azure function, but it can be anything that you want. Actually, in some cases, you may be able to bypass the function altogether. So for example, we have a capability to, I mentioned Slack, so you can actually directly create a Slack message for somebody, or you can actually, if you run everything on Databricks, right? So if you do the testing and the deployment on Databricks itself, you could trigger a Databricks job right through the webhook itself. So you just in that webhook, you would just say it's job 3742, and it would then automatically trigger it. Right? So and this will then all be defined. What these endpoints are will be defined in the corresponding documentation for the webhook.
And this segues way into the other question that Jay asks on the Zoom. Is it, could you show, or at least you joined the session later, but how would the unit tests be, the results of the unit tests be delivered as part of the CI/CD? So if I create a webhook and I want to run the unit test, how would I communicate back the results? Should I log it somewhere? Should I use the webhook to send a notification? Should I put it somewhere, send the results as email? What advice would you give in that particular scenario?
Yeah, so there's a whole bunch of options here, right? So in this case, I simplified it. So what I'm doing is within the pipeline itself, there's variables that you can use, right? So typically you wouldn't do that for, hundreds of thousands of data items, right? In this case, you can just define variables that say that was successful, or maybe this was the result of it, or this is the corresponding REST API, and you can use pipelines to basically hand those things back and forth. If you're producing maybe a data set or something, you would maybe provide the link to the storage location of that. So maybe it's a Delta link to like a Delta storage location on cloud storage. That will be an option, and there's a couple more. But again, in this simple scenario, I'm basically only handing back and forth,
right.
individual values, within the pipeline itself.
I mean, one of the things that webhooks allows you to do is that you can actually decide how you want to send back the results. You can either send it by email, or you can actually have a Slack message associated with that. Or as Oliver pointed out, you can actually have some environment variables that can be sent as part of the message back as a response to say, here are the unit tests, and you can actually, this could be a file or something. But actually, that's actually a good feedback. We're going to take that to the engineering team to say, hey, what are the other mechanisms whereby we can actually create these results and notify them. But today, most of the DevOps people either get an email notification, or Slack is an important part of GitHub. GitOps is another way to convey those results. So good question. Another one, I think we probably have a time only for the last one before we actually wrap up. After this comes from Dennis Liu from LinkedIn. After we have deployed the machine learning model into production in Databricks by enabling the model serving, could the Power BI access tool access it to make the prediction in real time?
So it's a question about Power BI to access the result of it?
I mean, what you're saying, let's say we actually deployed the ones that we did today. Let's say we actually did the flour, the wine testing that we actually deployed. And once we have gone through the entire CAD part, we deployed it in production, and we enable modal serving on Databricks, which gives you the ability to go and provide a URL or an endpoint. Now, if that endpoint is public, I think the person is asking, can an external tool, let's say Tableau or Power BI, can do prediction with that particular endpoint? It would seem that you should be able to do that. So if they actually have a REST point, which is public, being served on the Databricks endpoint, the BI tool can actually take. Go ahead.
Sorry, So I think the answer is, so when you use just to explain this is, rather than deploying this on Azure ML, you can actually use a Databricks endpoint as well. So we have a single node serving mechanism right now, which may actually be fine for certain scenarios, and we are actually, working on enhancing that going forward. But so you can actually create a REST endpoint that will actually create a REST API. If I click the enable serving here, so I'm not sure right now, just to be honest, that if you could access the information other than through the REST API. The REST API certainly would give you the way of doing that, but there may be also a way to store it in a managed Delta table or something, and then you could use as soon as it's in a Delta table, you can connect any BI tool to the cluster or to the SQL endpoint and access it. But I'm not sure how exactly that would work. So I don't know the full answer to this question.
But I suppose if the endpoint was public, then any application could actually just make a REST call with the test data to infer the score, wouldn't there be?
Yeah, again, anything that can trigger a REST call, you're right. But again, if they think about Tableau, I think more like a JDBC connection or something, right? So that would mean the data would have to be stored somewhere. And
yes.
I don't think that's happening by default. So something else would have to happen probably.
And I guess if you're doing it real time, then you're actually sending one request at a time to get the data, and the data could be a part of the JSON workflow that actually goes to the endpoint. Okay, I think that's all we have. Karen, do you want to wrap things up and probably just tell them how they can actually get access to this recording, and possibly once the public repo is available from Oliver, we can actually give them access to that.
Yep, absolutely. Yeah, thanks so much, Oliver. Really appreciate you presenting today. Thanks, Jules, for hosting as well. And yes, so I posted in the Zoom and LinkedIn and YouTube chat spaces where the recording is available. It's already up right now on YouTube, so you can check it out there. And then same with, I posted the GitHub repo, the GitHub link, and we'll get those resources up and posted there as soon as possible. So you should be all set with follow-up materials. And so just a quick thanks for everyone for joining us, and I hope you have a great rest of your day. Take care.
Thank you.
Stay safe.
Thanks so much. Bye.